Okay, so last month I did a session on Docker containers, and this is a follow-up session on Kubernetes. And just like last time, I won't be touching upon Kubernetes and SAP Cloud Platform. This is just a getting started, quick and dirty Kubernetes session. So the agenda for today's session, I'll talk about what is Kubernetes, why we need to use Kubernetes, the architecture of Kubernetes. I'll talk about the desired state management. We'll do a quick demo of Kubernetes, and also we'll talk a little bit about Cloud Foundry versus Kubernetes. So a quick recap of what we did in the previous session. We looked at Docker Hub, which is a centralized image repository in the cloud, where you can find and pull images of official libraries. And that's exactly what we did. We searched for the official Nginx image and pulled that image to our local laptop, and our local laptop was running the Docker engine. So we then spawned an instance and ran an instance of this image. This is the Docker container on our local laptop. So we ran the Nginx image on our local laptop. From there on, we even created our own Nginx image by using the official Nginx image as our base model. So this customized Nginx image, we had the gzip compression, and also we modified the HTML contents as well. And as a last step, we pushed this new Nginx image that we created to the Docker Hub. And this is what we did in our previous session. So we'll start off from that session onwards. So what is Kubernetes? Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. So in the previous slide, we had created a customized Nginx image. We even ran a single instance of this customized Nginx image on our laptop. So now what? What is our next step? Let's say demand is extremely high, and we need to run like multiple containers, even say possibly 100 containers. Also, another classic example for why Kubernetes should be used in the Kubernetes world is an application that has spikes in demand. Say, for example, in the morning 9 a.m. to 10 a.m., there is a significant spike in demand, and also from 5 p.m. to 6 p.m. Throughout the day, not so much. So how do you scale in such scenarios? So investing in static resources that can meet the peak demand, it would surely be a waste of time, or waste of resources, as it is not utilized to its full potential throughout the day. Kubernetes is a way to manage containers. So if we need to manage hundreds of containers, the best way to do it is with automation. And that's exactly what Kubernetes does. Kubernetes can automate all of this container stuff. So if a container crashes, Kubernetes has the smarts to create a new one automatically. And how does a container know which computer to run on? Kubernetes can do that for you as well. It can check with a scheduler, select the appropriate node to run on. And Kubernetes is also smart enough to automate rollouts, rollbacks, etc. So this is the diagram that we saw last time. We have the operating system, the container engine running on top of it, and this is where you can run all your containers. So what we saw is we don't need a guest operating system, and therefore running these containers, they require just a very small footprint. Kubernetes can manage these containers in an automated fashion. It is easy to interact with. Kubernetes is also an open source project started at Google. It now lives under the Cloud Native Computing Foundation. This is a vendor neutral home. And Kubernetes also has strong community support. So in the market, there are other container orchestration tools as well. Docker Swarm, Apache Mesos, etc. So why is Kubernetes so popular? Why is it being adopted widely? In a single word, Google, or one might even argue the relative lack of. So Kubernetes benefits from Google's original engineering and Google's hands-off approach to ongoing development efforts. So Google has been running containerized workloads in production for more than a decade. So Kubernetes traces its lineage directly from Borg, which is Google's internal cluster management tool. And apparently when the idea surfaced internally at Google that they would take this main tool, this main Borg tool, and make it open source, a lot of folks, including Google's head of technical infrastructure, they were kind of shocked when this idea was proposed. But that's exactly what Google did. They took their main weapon and made it open source. So it has more than a decade worth of Google engineering behind it. And after they made it open source, Google has been pretty much, they've had a hands-free approach to the Kubernetes project itself. They haven't been trying to manipulate Kubernetes to meet their needs. So Google claims that their motivation behind Kubernetes boils down to noble intentions. And of course, to a certain extent, that customers might now view Google Cloud Platform as a rich platform for containerized applications. And therefore, if customers do need to run containerized applications, they might go towards the Google Cloud Platform. Okay, so before we delve into what is Kubernetes, there are a few terminologies that you need to be aware of. The first thing is what is a pod? So pod is the basic unit that Kubernetes deals with. For the most part, you can think of a pod as a single Docker container. So in our previous example, last month when we did the session, we ran an Nginx container. So technically, you can think of a pod as a Docker container. But a pod can also have one or more application containers that are tightly coupled. So we'll look at that as well. So in our first example right here that I'm showing, we have a single Docker Nginx container. This is typically the most common use case. Since we are dealing with deployment of a single container, you can, for the most part, replace the word pod with container. So pod is the basic unit that Kubernetes deals with. However, there are cases where multiple containers work together to produce an artifact or process a set of work. So in this example that you see here, we have an Nginx container that uses MySQL container for data storage. They both need to work together. So instead of having these two containers in separate pods, it is much easier to couple them together because they're tightly coupled in a single pod. So in this case, the pod comprises of both these containers. The containers within the pod can communicate with each other via localhost. So because they can talk to each other using localhost, the communication is much faster instead of having to do any kind of virtual port mapping. So the next terminology that you need to be aware of is what is a node. A node provides computing resources necessary to run your containers. So think of your laptop as a resource for running containers. So you can think of any kind of hardware as for the node. So each node, it has the services required to run pods, and it is managed by a master node. So here in this example, you see that there is a node, and this node contains a single pod. Now, based on the resources within the node, you can run multiple pods. So here in this example, we have a node which is running 2 pods Each pod has a single container inside of it. And based on resources, you can run as many pods as you want in a single node. So a node can have like, say, 10 pods or so. Okay, so in this slide, we'll talk about the container cluster, so the architecture of the Kubernetes engine. So the container cluster consists of one cluster master, and it typically has one or more nodes. So these nodes are the worker nodes. As the name suggests, the master is responsible for managing the cluster. So it coordinates all the activities in your cluster. It is responsible for scheduling applications, maintaining application desired state, scaling applications, and rolling out new updates, rollbacks. So everything the master controls. So the master runs the Kubernetes REST API server. It runs other processes as well, but the API server is the key. This is how you communicate with it. So all interactions with the cluster are done via Kubernetes API calls. So you talk with this API server and you direct what the master should do. So you can make Kubernetes API calls directly via HTTP, or you can also use what is called the Kubernetes command line client, kubectl. So in our demo, we'll just use the kubectl, but you can also use the REST API calls as well to talk to this API server. So speaking of nodes, the nodes are worker machines that run your containerized applications. Or in other words, a pod always runs on a node. Each node is managed by the master. So we already saw that the master is responsible for managing all the nodes underneath it. Nodes also run the Kubernetes node agent, kubelet, and this allows it to communicate with the master server. So all nodes have like a kubelet process that allows it to communicate with the Kubernetes master. So as a developer, we want to run containers in these nodes. So how do we accomplish this? So as a developer, you can interact with the Kubernetes server, which is running the Kubernetes API server, which is running on the master. And what you typically do is you provide a deployment.yaml file. So this deployment.yaml file, it kind of tells the API server what you want to do. So you may want to run our Nginx image. You may want to run 3 copies of it. So all of that information is contained within this deployment.yaml file. So here in this YAML file, say we have a deployment. We say I want to run the Nginx image, and I want to run 1 copy of it. So the master makes the determination as to where it can run this single copy. So it can either run on, we have 2 nodes here, so it can either run on this node or the other node. So the master makes that determination, and it says, hey, I'll run this pod on this node. And say the developer now wants 2 copies of this Nginx image. So he makes a change to this YAML file. So he changes it to now 2 copies. So now the master recognizes that there is a change, and it can make the determination where to run this other pod as well. So in this case, it figures out that the node has enough resources to run 2 pods. Therefore, it chooses the same node to run the other pod as well. And say you want 4 copies, the master makes that determination, and it can run it, and it makes sure that we have 4 pods. So in Kubernetes world, there is the concept of a desired state and actual state. So the desired state is what is in the YAML file. So in this case, the desired state was replica 4 copies. So Kubernetes master constantly figures out what the actual state is. So if the actual state was only running 2 pods, then it makes all efforts to match the actual state with the decide state. And therefore, it would go ahead and spawn 2 other pods. And similarly, if you only wanted 2 pods, again, the Kubernetes master figures that there are 4 pods running, and the actual state is 4. The decide state is 2, so it would go ahead and kill 2 pods. So there is always this constant trying to match the actual state with the decide state. So Kubernetes itself consists of various components, and in this session, we'll look at deployments. The reason why I chose deployments is this is the most important component of Kubernetes. So in this session, we'll look at deployments. So a deployment controller, it provides declarative updates for pods and replica sets. So basically what that means is you tell Kubernetes, hey, this is what I want. You don't have to tell Kubernetes how to accomplish it. You basically tell Kubernetes, hey, this is what I want. So you could say something like, I want to run my Nginx image, and I want to run 5 copies of it. Or you could even say, I want to run the Nginx image and the MySQL image, and I want to run them as a single pod, and I want to run 5 copies of it. So you just tell Kubernetes what you want, and Kubernetes will accomplish it for you. So in this example, first example, so I have a deployment YAML file. I want to run my Nginx image, and I even specified the version 1.7.9. And replicas, I said I want 3 replicas. And Kubernetes will do that for you. It will accomplish this goal for you. And say you want to update your deployment. So the Nginx image 1.7.9, now you want to run 1.9.1. So you just run a command. You just tell Kubernetes, hey, I want to run 1.9.1. And Kubernetes will do all the hard work for you. Now say that you messed up this deployment. The image is incorrect. So you just tell Kubernetes, hey, I want to roll back. And Kubernetes will do this. It'll go back to the previous deployment. And scaling is pretty straightforward as well. You just tell Kubernetes that you want to scale up to 10 Nginx pods, and Kubernetes will do it for you. And you can also pause the deployment. Say if you want to make 5 or 6 changes to the Nginx image, but every time you make a change, you don't want the image to be rolled out. So what you can do is you can pause the deployment, make all the changes to the existing image, then you can resume the deployment, and now the changes are all deployed. So in today's session, so you say if you're new to Kubernetes, you could use a variety of cloud services out there in the market to try out Kubernetes. They all cost money, of course. So Google, you can sign up for a free trial, but they all cost money. So what you could do is there is a tool called MiniKube. This allows you to run Kubernetes locally on your laptop, and that's what I've done. I've installed MiniKube on my local laptop. This runs a single node Kubernetes cluster, and this is a good tool for you to learn Kubernetes before you start playing in Google Cloud or Azure or maybe even SAP Cloud Platform later on. So this is a really good tool for you to get familiarized with Kubernetes, how deployment happens, and so on. Or you can try out deploying your containers in MiniKube first before you do it in actual production. So like I said, the architecture is the same thing, is identical to Kubernetes, except it's a single node. So like in the previous slide, you must have seen that there were 2 worker nodes. But MiniKube just provides a single node. So same kind of the developer provides the YAML file, and the YAML file, say if there is a replica of 1, it will run it in this node. There's only a single node, so it will keep running all the pods in the single node. Developer changes it to 2. Now there are 2 pods, changes it to 4, all 4 running on the single pod. So single node, yeah. So this is what we'll use. We'll use MiniKube to learn about the basics of Kubernetes. Having said that, we can quickly go into a demo of Kubernetes. So I have MiniKube installed on my MacBook Pro. So installation is fairly simple. It wasn't too complicated. So if you have a MacBook Pro, as long as you have the latest OS, then you should be all set. So it's fairly, you can just download MiniKube, and I believe you also need to install VirtualBox, some kind of a virtual machine tool, and then you're all set. So I have MiniKube installed, and at this moment, let me run MiniKube status. Okay, so there's nothing in it. Like, so I've just installed. It's not running. It's brand new. Okay, so you have MiniKube, and there's nothing running. It's brand new. So we'll start with a clean slate, like we did last time. So what I'll do first is I'll start MiniKube. So MiniKube start. Now, what this does is it'll start a single node. And this will take about a minute or so. So in the meantime, what we'll do is we'll talk about the deployment file. So I'm the developer here, and I want to run an image, and this is my YAML file, the deployment file. And basically, what I'm telling here is I want to run this image, and this is the image that we pushed to the Docker hub in the last month's session. And I want to run 3 copies of it. And I am also telling that this deployment, I want to name it as Nginx deployment. So the YAML file has a peculiar format. But it's not very. It's fairly easy. Just key value pairs. And in this YAML file, I'm just telling that I want to run this Nginx image. I want to run 3 copies of it. And this deployment itself, I've named it as Nginx deployment. And let's see where we are. So it's still starting the VM. It's almost done. Now, once we, let me also log into Docker container as well. Yes, so once this MiniKube starts, it will create a single node cluster. So we will have a single node cluster where we can run all our pods. Okay, so let me also log into Docker. Okay, so MiniKube also comes with a dashboard, and this is the same dashboard for Kubernetes as well. This kind of gives you an idea in UI format as to what is running in Kubernetes at this time. So it opens up this dashboard, and you can see that if you go into nodes, it's only a single node. There's only one node. And if I go into deployments, there are no deployments because this is a brand new install. There are no replica sets, so nothing running on the Kubernetes except the single node. Now, what we want to do now is we want to go ahead and deploy this YAML file. So I'm going to run this command. So this deploys this YAML file. And in this YAML file, I've mentioned militancy, this zip file, this image, and this image resides in the Docker hub. So when I deploy this YAML file, Kubernetes is smart enough to go to the Docker hub, pull this image down, and immediately run 3 copies of it. So I can run this command here. And oops, maybe cd docker. Okay, so it immediately created this deployment, and if I go into this UI nav, I will see that I have a deployment, and you can see that there's already three running pods, and it says the image is 1.0 because that's the image that I wanted to run. And I come into these pods, and already all these three pods are running. So it was able to go to the Docker Hub, pull all that for me, and immediately start running it. So it's fairly like you just tell what it needs to do, and it immediately starts running it. And then say I can also check it using the command line. I can do a get deployments. So this is a command line version of what we saw on the UI. So it says the decide is 3 and the current is 3. It's up to date, so everything is good. I can also see the pods using the kubectl commands. Now, when you run this kubectl, it's basically talking to the master, which is running a REST API server. You can also do the same thing using REST commands as well, like HTTP commands. And you see that there are 3 pods running. Now what I want to do is I want to expose this container so that I can actually see that it is actually running. I don't believe this. I run this, and load balancing comes for free. So I expose this. Now the service is exposed. And if I go to this, I want to find out what the URL that it's exposed as. And this is the URL where my containers are exposed. And like I said, it's load balanced. And if I go here, then you will see that the containers are running at this moment. So this is version 1 of the customized Nginx container. Now what I want to do is I want to deploy, I have another version 2 of this image. So I want to set this image on the deployment file to version 2. So I run this command kubectl. And at this time, we were running version 1. So I just run this command saying, hey, I want to update this version to version 2. I run this. And if I go into my web UI to this dashboard, and I go back to deployments, and you will notice that it's now running version 2.0. So it immediately updated my image for me. And if I go into my pods, it's all now running the new image, the 2.0 image. Now, say if I made a mistake and I didn't actually want to go to 2.0, so there's, I'll show you how we can roll back from the UI. So in the UI, it has the same YAML file that we deployed. So we can go into this YAML file. We can also run it through command line, but I wanted to show both the UI and the command line. So I can go to this YAML file, and I can say, hey, you know what, I made a mess up. Let's roll back. Let's go back to 1.0. I do an update, and now it says 0 of 3, so it knows that the decide state is actually 1.0. So it's it'll stop all the pods. So now you see it's just running for 6 seconds. So it stopped all the 2.0 pods and went back to 1.0. So as simple as just changing one line, and all of a sudden you have all these pods running. And it's so easy to use. You as a DevOps guy, you are like, this makes life so much easier to roll back, roll out everything. So I roll back using the dashboard. Say if I wanted to change, I wanted to scale, so I can do a scale deployment. I wanted now 6 replicas instead of 3. Demand is high, so I just say replicas is 6. And if I go into my UI, I will see that I now have 6 pods running. So it immediately figured that my desired state is 6 and that I only had 3, so it spawned off of 3 more. If I wanted to reduce the scale, I can go here. I can run it through command line or from here itself. I can edit the YAML file, change the replica to say, let's say 4 this time. And Kubernetes is smart enough to, it will immediately kill. So I came fast. You can see that it's terminated. So there's now only just 4. If I come back, it should only have 4. And all this so automated. So you as a DevOps guy, you just tell Kubernetes what you want, and Kubernetes does this thing for you. So now let's say we want to do a deployment, but there are like multiple changes that we want to make to the image itself. So I don't want to like, every time I make a change, I don't want Kubernetes to deploy. So what I can do is I can pause the deployment. So right now, let's see, Kubernetes should be running, I think, 1.0. Let's see. Yeah, so Kubernetes is running the 1.0 version of my container. And what I want to do is I want to go to 2, but I don't want to, but there are a series of changes I want to make. What I'm going to do is I'm going to pause the deployment for now. Oops. So the rollout, I want to pause it. So, but the container is still running, so we can make sure that the pods are still running. So it's still running version 1.0, but the deployment itself is paused. So now I can make the necessary changes. So first I will change the image to 2.0. I will change the image to 2.0. And if I go, because the deployment is paused, this will still be running the 1.0 version of the Nginx container because the deployment is paused. And say I make some changes to the resources. I change the memory to like 512. Like let's say I also changed the CPU. So I made all the necessary changes, like I made the 4 or 5 changes that I wanted to make. Now I can go ahead and resume the deployment. So I go ahead and resume the deployment. Now if I go to this web page, now it should, since we, oops, still doing it. Deployment is resumed. Yeah, so this is now version 2 of the Nginx container. So now the deployment is resumed. It automatically went to the 2.0 container. So Kubernetes is an awesome tool or awesome platform for DevOps guys. It makes everything so much easier, and you can quickly roll out, roll back, change images, and everything that you want to do. And I can go ahead and I guess stop and delete this MiniKube if I want. So MiniKube stop. So this is a local version. Oops, yeah, and now it will stop all my Kubernetes cluster, and I would not be able to go to this web page anymore. Yeah, any questions so far?